The purpose of this stage is to extract gold-bearing rock from its natural geological formation and deliver it as raw material for industrial processing. Gold at this point is not visible. It exists in low concentrations embedded within hard rock structures. Mining operations begin with geological surveys and drilling programs that define the ore body and determine extraction zones. Hydraulic drilling rigs create precise blast holes, followed by controlled blasting designed to fragment the rock while maintaining structural stability of the mine. Once fragmented, large hydraulic excavators load the ore onto heavy-duty haul trucks designed for continuous operation in harsh environments. These machines operate in a coordinated sequence to maintain a steady flow of material without interrupting downstream processes. The primary input of this step is the intact gold-bearing rock within the earth. The output is broken ore, reduced to transportable size and moved from the mine face to designated collection points. At the end of this stage, the material remains unprocessed chemically. Its value solely lies in its mineral content. The extracted ore is now ready to be transferred to the processing facility for further mechanical and chemical treatment. Part 2. Reception and primary evaluation of raw ore. The purpose of this stage is to formally receive the mined ore and prepare it for controlled industrial processing. This step ensures material consistency, traceability, and process stability before mechanical treatment begins. Haul trucks deliver the ore to the processing facility where it is unloaded into reinforced receiving hoppers designed to handle high-impact material. Automated weigh scales record the mass of each load as it enters the system. From the hopper, the ore moves on to conveyor belts equipped with metal detectors and sampling units. These systems collect representative samples to determine grade content, moisture content, and rock composition. Based on this data, the material is routed to designated stockpiles or directly into the crushing circuit. This sequencing allows the plant to balance throughput and optimize downstream performance. The endpoint of this stage is fragmented gold-bearing ore from the mine. The output is measured, classified, and logged raw material, ready for size reduction and further processing. The purpose of this stage is to reduce the raw ore into smaller, uniform particles in order to liberate gold from the surrounding rock. This mechanical size reduction is essential for efficient separation in later processing stages. The process begins with primary jaw crushers that break large rocks into manageable fragments. These fragments are then transferred by conveyor systems to secondary cone crushers for further size reduction. After crushing, the material enters grinding mills, typically ball mills or semi-autogenous grinding mills, where rotating steel media reduce the ore to a fine slurry. Water is added in controlled amounts to support continuous milling. Sensors and automated controls regulate particle size, mill speed, and material flow to maintain consistent output quality. The input of this stage is classified raw ore from reception and stockpiling. The output is finely ground ore, prepared as a slurry and ready for chemical or physical gold separation in the next step. Part 4. Gold separation and concentration. The purpose of this stage is to separate gold from the finely ground ore and concentrate it into a recoverable form. At this point, gold particles are physically and chemically accessible, allowing controlled extraction to begin. The process starts by directing the ore slurry into large agitated tanks or separation circuits. Depending on ore characteristics, gravity concentrators, flotation cells, or chemical leaching systems are used to isolate gold-bearing material. In gravity-based systems, centrifugal concentrators separate gold using differences in density. In chemical circuits, controlled leaching solutions dissolve gold while leaving most other minerals behind. Throughout the operation, flow rates, chemical levels, and retention times are monitored by automated control systems to maintain stable separation conditions. The input of this stage is finely ground or slurry. The output is a gold-rich concentrate or solution, separated from waste material and prepared for refining and purification in the next stage. 5. The purpose of this stage is to remove remaining impurities from the gold-rich concentrate and produce gold at a defined industrial purity. This step converts extracted material into a standardized metal suitable for casting and commercial handling. The process begins by transferring the gold concentrate or gold-bearing solution into refining units. Depending on plant design, this may involve smelting furnaces, electro-refining cells, or chemical precipitation systems. Each method is selected based on ore chemistry and required purity levels. In thermal refining, the material is heated in high-temperature furnaces where fluxes are added to bind unwanted metals. These impurities separate from the molten gold and are removed as slag. In electro-refining systems, electric current drives gold ions to deposit onto cathodes, leaving impurities behind in solution. Throughout the operation, temperature, electrical current, and chemical balance are continuously monitored by automated control systems. This ensures stable conditions and consistent metal quality. The input of this stage is gold concentrate or gold-bearing solution containing residual impurities. The output is refined gold with controlled purity, typically exceeding industrial standards, ready for melting, molding, and final product formation in the next stage. 6. The purpose of this stage is to convert refined gold into standardized physical forms suitable for handling, storage, and commercial distribution. At this point, gold meets purity specifications and is prepared for precise shaping. The process begins by feeding refined gold into induction furnaces or high-efficiency electric melting furnaces. These systems heat the metal under controlled conditions to achieve a stable molten state while minimizing oxidation and material loss. Once fully melted, the gold is transferred through insulated channels or ladles into automated casting machines. The molten metal is poured into calibrated molds designed to produce bars or ingots with exact dimensions and target weight. Cooling systems regulate solidification rates to ensure consistent internal structure and surface quality. After cooling, each cast unit is mechanically released from the mold and transferred to inspection stations. Automated weighing systems, surface scanners, and marking equipment verify mass, shape, and identification data. Serial numbers or batch codes may be applied for traceability. The input of this stage is refined gold in solid or granular form. The output is fully formed gold bars or ingots, uniform in size and specification, ready for final inspection, packaging, and secure distribution.
7. The purpose of this stage is to protect the finished gold products and confirm that each unit meets documented specifications before leaving the production facility. This step ensures physical security, traceability, and compliance with industry standards. The process begins as gold bars or ingots arrive at the packaging line from the casting area. Automated handling systems position each unit into protective casings designed to prevent surface damage and environmental exposure. Sealing machines apply tamper-evident closures, while labeling equipment adds identification codes, weight markings, and production data. These markings link each item to its manufacturing records. Quality control systems then perform final checks using calibrated scales, optical scanners, and documentation verification software. Any unit outside tolerance is removed from the line for review. The input of this stage is fully formed gold bars or ingots. The output is securely packaged verified gold products ready for controlled storage and dispatch from the facility.
8. The purpose of this stage is to transfer packaged gold products from the production facility into secure ground transportation for delivery to storage centers, refineries, or financial institutions. This step completes the manufacturing process and initiates controlled logistics. The process begins in the dispatch area, where packaged gold units are grouped by shipment and placed into reinforced transport containers. These containers are designed to resist impact, unauthorized access, and environmental exposure. Automated palletizing systems organize the containers onto standardized pallets. Forklifts or automated guided vehicles then move the pallets to the loading bay in a predefined sequence. Trucks used for transport are purpose-built vehicles equipped with reinforced cargo compartments and locking systems. Loading is carried out under supervision, with each container scanned and logged before being placed inside the truck. Once loading is complete, the cargo compartment is sealed and transport documentation is finalized through digital tracking systems. Vehicle identification, route data, and departure time are recorded. The input of this stage is sealed and verified gold packages. The output is secured cargo loaded onto transport vehicles and released from the facility, ready for controlled overland distribution.